So what does it mean if I ask you about what is a system of equations? What is a system of equations? What do those words mean? More than one, right? Using your context clues, we know that there's more than one. And you know that because what we're dealing with right now, one of them is going to be linear, and the other one's going to be quadratic. Okay? How do you tell the difference between one and the other? Linear is a straight line, quadratic is a parabola, right? If I just gave you the equations, could you tell the difference between those two? How do you tell the difference between a line and a parabola just by looking at the equation? A quadratic has a squared, right? A quadratic has a squared in it. So, for example, in this system right here, is that the linear or is that the quadratic? And how do you know that? It doesn't have a square, okay? What about this second one right here? Is that the linear or the quadratic? And how do you know? It has a square, right? How do you know how to solve a system of equations? You know 3 ways. Well, you know 4, but 3 that we can use here. What are they? Graphing, good. Let's list them so we have them down. Substitution and elimination. Good. Those are the 3 ways that you know to solve systems of equations, right? And what's the 4th way you know? A matrix. And why can't we use that here? Because of the squared, right? Because we have a quadratic here. Okay. So, how do we solve this by graphing? That seems like a super obvious question, doesn't it? How do you solve it by graphing? You graph it, right? What are you looking for when you graph it? So for graphing, we're looking for the point of intersection or where they cross, right? P-O-I-N-T, point or points of intersection. For example, if I have a line and a parabola, and it looks like that, what does that mean? What does that mean? No solution. And why? Because they don't cross. Okay? If we have a parabola and a line like that, what does that mean? One solution. Because it crosses in one place. In geometry, that was called a what? Do you remember? Starts with a T. A tangent, right? A tangent, okay? And what about here? 2 solutions. One's there and one's there. You okay so far? So how do I go about graphing this? He said on my calculator. Are you okay with that? Yeah, for sure. Except if I give you a graph on a test, what am I expecting? Just like a real quick sketch? No. Right? If we're solving it by graphing, we need to see points, like exact points that we want to see on our graph. Okay? We need to see the exact points. My calculator's being rude. So I want to go to my graph. I'm going to zoom in so you can see my calculator. I'll be able to see the equations, but you have them written down, yes? So x plus 5 is my first one. And then tab to enter my second one. X squared plus x plus 4. So what do you notice? You notice that there's 2 solutions. Does anyone else notice anything else? What do you wonder? Why the line keeps going or if the line keeps going. That's fine. That's fair. Either one of those is okay, right? Now, if we think about it for just a second, is that line going to keep going? Yes, but we wonder that at first, right? Is the parabola going to keep going? Or does it stop right there and right there? It definitely keeps going as well, right? Does anybody else notice anything or wonder anything? We good? Okay, so you notice that there was two solutions. Where are they? Where they cross each other, right? So one of them is right here, and one of them is right here. How do we go about finding out where those solutions are? Okay, we can do that. Menu, which is analyze, and then 4, which is intersection, right? Now what? I just draw a line. So I scoot this over, click it. Can I make it tell me both at one time? No. Can't really see that, so I'm going to move it over so it's clear. -1, 4. Now what do I have to do to figure out the other one? Same thing. Menu, analyze, intersection. I want this on the left-hand side of the point of intersection, and then the right-hand side of the point of intersection. Is that it? Yes. Okay. I'm going to zoom back out for a second so you can see my work. So what we found using our calculator was -1, 4, and 1, 6. Are there always two solutions? No, in fact, we just talked about when there's not, right? Didn't we? Okay? But if there are two solutions, you need to find both of them, don't you? Okay? So if I gave you this question on a test and required a graph, like I said, I don't just want I want exact points so I can see exactly where they cross, because I've given you a graph to prove what you found using your calculator, right? How do you find the exact points besides these two that I know are points of intersection? Zoom back in. Control T. Here's a table. Here's my line. Here's my parabola. Here's my x value and my y value for my line. Here's my x value and my y value for my parabola. Go plot those points. Yes? That didn't sound rude, did it? It didn't? Okay, good. I said that didn't sound rude, did it? Okay, good. Just making sure. Do you have any questions? Okay. How else do we know how to solve a system of equations? Substitution. Okay? So what I would like to do is I would like to solve this problem that we just solved by graphing using substitution. Why would I do exactly the same problem when I already know the answers? Yeah, the answers don't matter, do they? It's the process. It's the knowing how to do the substitution. We already know how to the answer, so we should get the same answer, just like he said, right? Okay? So if I'm doing substitution, what's my goal? By definition, what am I doing? I'm substituting one into the other, right? If I know y equals x plus 5 and y equals x squared plus x plus 4, what should I do with x plus 5? Substitute it in for y, right? I'm going to draw that out for you, and I know that seems weird, but I also don't care, okay? Here's what I mean. If I know that y equals x plus 5, I want to take x plus 5 and put it right there. Substitute it into the other equation. Now, this time y's are both out here, right? But sometimes it might be over here. It doesn't matter, right? What if I solve this equation for x? Where would I have to put it in? Here? Oh, here and here? Yeah, both places. Anywhere there's an x, if x is what's solved for. Y is what's solved for here, so I'm just going to use what is given to me and substitute it into the other equation. You okay with that? Okay. Now, if you had a choice, what if it said like x plus y equals 5? I know that's not the same as this, but I'm saying if you were given something like x plus y equals 5, which one would you solve for? Doesn't matter. No, it does not. Okay, so just keep that in mind, all right? So if I take x plus 5 and substitute it in for y, my new equation actually says x plus 5 equals x squared plus x plus 4. You okay with that? Now what? Yeah, I need to, right? I need to get it equal to 0, and I'm going to do that by combining like terms. I'm going to subtract x from both sides. I'm going to subtract 5 from both sides. So 0 equals what? X squared. Ooh, that's nice, right? Isn't it? Well, this is an x and a minus x. So that would just be 0, right? Minus 1. Okay? Now, I have two options, well, that I can think of off the top of my head. Two options right here. Which one, what would you like to do? How would you like to solve this? So add 1 to both sides. 1 equals x squared. Take the square root of both sides. What's the square root of x squared? What's the square root of 1? I was crossing my fingers that you would remember. What is the square root of 1? What times itself equals 1? I agree with that, but what else times itself equals 1? Negative 1. Plus or minus 1. Remember that? Do you remember that? Good. Yeah. You just forgot part of the answer. That's what you did wrong. Okay? So, what does this tell us? Like, what does this actually mean? Yay, we can do math. What does it mean? X equals 1? N equals negative 1. So what did we just discover? Two answers, right? There's two solutions. One of them looks like 1 something, because it's x, right? And one of them looks like negative 1 something. Does that make sense? How do I figure out the something? How do I figure out the y? So you want to go to the top one? Could I use the second one? Why would I not? Yeah, it's harder. I want to choose the easy way, right? So what's 1 plus 5? Ah, excellent. What is negative 1 plus 5? Done. That is my answer. And I know it looks something like this. And the problem might be upside down. It's not. You can tell that, right? But it's this way and it crosses twice, once at 1/6 and once at negative. Well, we already knew that though, didn't we? Because we already graphed it. But do you understand what this means when we compare it then to the graph? We already knew what we were going to get as our answers. Right? But do you understand when I solve for x and I get a positive and a negative, that's telling me I have two points of intersection. Okay, any questions about this? So what about if I ask you to do the same exact problem, with elimination. You're like, seriously, Kingston, the same problem again? Yes. You have to know all the ways. You might as well just use the same problem, because once again, the answer is not what's important. It's the solving it, right? So we have y equals x plus 5, and we have y equals x squared plus x plus 4. How do I go about solving by elimination? So I'm going to add them together and hope something goes away? Oh, so I'm going to add them together and make something go away. Yes, okay. So do I have to do something first before I can add them together? Sometimes, right? In this case, do I have to? Yeah, because if I added them together right now, I'd get 2y, an x squared, 2 x's, and 9. Nothing went away, right? Which variable do you choose to eliminate in this problem? We definitely want to eliminate the y in this problem. Why do we not want to try to eliminate x in this problem? Yeah, the top one doesn't even have an x squared, does it? Okay. First of all, the top one doesn't have an x squared, and even if it does have an x squared and an x, it may not be possible to eliminate both of them at the same time. And if we can't eliminate both of them at the same time, it's not worth doing, right? So do you see that we would want to eliminate the y first? Okay, how are we going to go about eliminating the y first? So you want to multiply the top one by a negative? If we multiply the top one by a negative, I get negative y equals negative x plus 5. Thank you. I think I said that and then wrote plus. Or did I say the wrong thing too? You knew that it should be minus 5 and you caught it for me, so thank you very much. Good. We multiply everything by, see how easy it is to mess up? Even I do sometimes, right? Okay? And that's fine. We fix it and we go on, right? That's a plus. That's a plus. Now if I'm going to combine these two exactly as they are, will one of my variables eliminate? Why? Why will y eliminate? Because they are the same number but opposite signs, right? Same coefficient, opposite signs. A negative 1 and a positive 1. So I add these together right now. What do I get? 0. Now we need to combine these the right way. I have an x squared here and not an x squared up here, so I just get x squared. I have a negative x and a positive x. That's 0. I have a negative 5 and a positive 4. Negative 1. Now, you remember a minute ago when we did this problem, we got to the same exact step? We are so smart, right? And remember what I said? I see 2 ways right away to solve this one. And I did the way that you saw. Can I do the other way, just to make sure you understand the other way? Isn't this a difference of squares? Can't I factor this to x plus 1 and x minus 1? And what does the zero product property say? Set them each equal to 0, right? Minus 1 minus 1, x equals negative 1, plus 1 plus 1, x equals positive 1. Oh my gosh. What does this tell me? Can I show you what at least 3 people did? They did this and circled that as the answer. Do you understand why they might do that? But that is bad. That's frowny face bad, right? Because this is x and this is y. These both say x. So what does that tell us? Those are our x's, and we have to go find our y's. We're going to go find them the same way we did over here, right? Negative 1 plus 5. 1 plus 5. 6. You okay? Do you feel any better about this? For real? Okay. Let me ask you a quick question, though, before we're done. Okay? What if I get to this point and decide I need to factor it, like we did here, and I try to factor and it doesn't work? What should I try? Quadratic formula, right? Definitely quadratic formula. Okay? What if I'm doing my quadratic formula? Here's a what if. What if? What if I'm doing my quadratic formula and I get x equals 2 plus or minus the square root of negative 18 over 6? Right? I've done all my work correctly and I end up here. What does that mean? That means because I have a negative underneath my radical, I'm going to end up with an I as part of my answer, right? I can get an answer with an I in it, can't I? I'm allowed to do that, right? But if I'm looking for a solution to a system of equation and I get an I as part of my answer, that means no solution, just like you said. Okay? And this right here, this is the proof that you got no solution. You don't have to like try to graph it or anything like that. That's the proof. Do you have any questions about that? Okay?